I run proxy farms for a living, real production infrastructure, residential and mobile IP pools feeding scrapers around the clock. I've spent more hours than I'd like to admit staring at a scraper that works perfectly on my laptop with curl and then falls over the second it's wrapped in a real browser. So when I tell you the proxy usually isn't the problem, that's not a guess, that's watching the same failure happen across enough different targets and enough different proxy providers that the pattern becomes obvious. And here's why blaming the proxy is usually wrong. The proxy's job is simple. It moves your bytes from your machine to the target server and back. That's it. In both the curl test and the browser test, the proxy did exactly that job correctly. What's different isn't the pipe the traffic travels through. It's everything wrapped around that connection. The NS handshake looks different. The HTTP headers look different. The JavaScript environment is completely different, and a real browser produces behavioral signals that curl never produces because curl doesn't render anything, it just fetches bytes. Sites that actually care about bot traffic are not just looking at your IP address and deciding pass or fail. They're checking whether the thing connecting to them looks like a real browser all the way down the stack, from the handshake to the rendered page to the way a mouse moves across the screen. Curl and the real browser look nothing alike to a server. It doesn't matter that both went through the identical proxy IP. The IP is one input among several, and it is very often not the one that's failing you. So let's actually look at what's different, starting at the network level. Curl is about as minimal an HTTP client as you'll find. It opens a TCP connection, does a TLS handshake using whatever defaults its TLS library ships with, sends whatever headers you told it to, or a small default set if you told it nothing, and reads back the response. That's the entire job description. There's no rendering, no JavaScript execution, no layout engine. It's a very thin wrapper around the network request. A real browser does a lot more work before a single byte of the actual page shows up on screen. Chrome, Firefox, and the Chromium engine that both Playwright and Puppeteer drive under the hood all ship their own TLS stack, and that stack has a specific consistent fingerprint, cipher suite order, extensions, supported groups, LPN settings, all of it. People call this a JAR 3 or JAR 4 fingerprint, and curl's fingerprint looks nothing like Chrome's fingerprint, because curl is built on a completely different TLS library with completely different defaults out of the box. Here's the part that trips people up. A detection system doesn't need to know your IP belongs to a proxy pool to flag your request. It can look at the shape of the TLS handshake alone and think this claims to be Chrome in the user agent header, but the handshake says otherwise. That mismatch by itself is a strong signal, and it has nothing to do with what proxy you're on. You could be on the cleanest residential IP on the planet and still get flagged purely on that mismatch. With curl, this mismatch often doesn't even come up, because curl requests usually aren't pretending to be a browser in the first place, unless you set a browser-style user agent manually. But even if you do that, set curl's user agent to say Chrome on Windows, and route it through a perfectly clean residential IP, you can still get flagged the moment the TLS handshake underneath doesn't match what a real Chrome handshake looks like. The user agent and the handshake get checked together, not separately. Automated browsers stack another whole layer of problems on top of the TLS issue. Puppeteer and Playwright run in a fairly default configurations straight out of the box, leave their own detectable fingerprints inside the browser itself. Things like navigator.webbrave being set to true, rendering quirks that only show up in headless mode, timing patterns in how JavaScript actually executes on the page. None of that has anything to do with the proxy sitting underneath it. At typoish to sadantes nubir seen by manjun by maida video omniscient. So let's walk through, roughly in order, what a detection system typically looks at when a request lands on it. And I say roughly because every site is different, but the layers themselves are pretty consistent across the industry, and understanding them is what actually lets you figure out which one is failing you instead of guessing. First layer is the TLS and HTTP fingerprint. Does the handshake actually match what the declared browser and operating system would produce in real life? Does the header order and capitalization match what that browser normally sends? Curl's header set and header order is not what a real Chrome install sends by default. And even in Playwright or Puppeteer, if you haven't replicated a real browser's header ordering, Your automation's default headers may not perfectly match a stock Chrome install, depending on version and configurations. Second layer is IP reputation, and this is the layer most people assume is the whole story, probably because it's the layer proxy providers talk about the most. Is the IP a known data center range? Is it part of a known proxy pool that's been flagged before? Does it look like it belongs to an actual residential or mobile subscriber? This layer is real. It absolutely matters, and a bad IP will get you blocked on its own. But it is one signal among several, not the entire decision. Third layer is the JavaScript environment itself. Once a page loads, or sometimes before it even finishes rendering, a site can probe things like navigator properties, canvas fingerprints, font lists, and automation tells like that navigator.webref flag I mentioned. Curl never executes a single line of JavaScript, so this entire category of check simply doesn't apply to a curl request. That's the single biggest reason curl tests and browser tests aren't comparable. Curl is blind to a whole layer of detection that browser automation walks straight into. Fourth layer is behavior, mouse movement across the page, scroll patterns, the timing between one action and the next, whether a captcha gets solved the way a person would solve it. Curl produces exactly none of this because it doesn't render anything. There's no page for a mouse to move across. A real browser produces all of it, and if the automation moves in obviously scripted patterns, constant velocity mouse paths, zero latency clicks, identical timing repeated between every action, that pattern itself becomes a signal a detection system can pick up on. So when a proxy provider sells you block-free scraping, what they're actually selling is the IP layer, and only the IP layer, that's it. That proxy cannot fix your TLS fingerprint. It cannot make Puppeteer stop reporting navigator.webdriver as true. It cannot make your click timing look like a human clicked it. If your browser test still fails after you've confirmed the proxy itself is genuinely clean, the proxy is very likely not the layer that's actually broken. So don't guess, test each layer separately before you conclude it's the proxy's fault, because you can burn a lot of money cycling through providers while the real bug sits untouched in your automation config. Step 1. Confirm the proxy's IP is clean on its own terms, completely separate from your scraper. Hit an IP reputation lookup through the proxy using curl. Check whether it's flagged as data center, check whether it shows up on known proxy or VPN lists, and check whether the SN matches what the provider claims to be selling you. A pool sold as residential or mobile should show an SN consistent with that, not the hosting provider's range. Step 2. Check what your browser automation is actually sending out over the wire. Route Playwright or Puppeteer through the same proxy to a header echo endpoint. Something like HTTP bin's headers endpoint works fine. And compare the header set, order, and user agent string against what a manually operated copy of that browser sends to the same endpoint. Any differences you find here point at the automation layer being the problem, not the proxy underneath it. Step 3. Check the TLS fingerprint on its own, separately from everything else. There are public Gen 3 and Gen 4 fingerprint test endpoints out there for this. Hit one with curl through the proxy, then hit it again with your automated browser through the same proxy and compare the results. If curl's fingerprint and the browser's fingerprint land in different buckets from what the target site expects a real Chrome to look like, that mismatch exists no matter how good the proxy is. Step 4. Check for automation tells sitting inside the JavaScript environment itself. Load a fingerprinting test page in your automated browser and look specifically at that navigator.webdrive flag, the plugin count, and any headless specific quirks the page picks up on. This one is entirely on your automation configuration. It has nothing to do with the network path or the proxy at all. So fixing it means adjusting how you launch and configure the browser, not switching proxy providers. Step 5. And only after the first 4 steps come back clean, do you actually treat the proxy itself as a suspect. If the IP checks out, the headers match a real browser, the TLS fingerprint matches, and the JavaScript environment looks like a completely normal browser, and the block is still happening specifically with that one proxy, then something about that proxy's routing, its latency, or its IP's history with that particular target site is worth raising with the provider directly. None of this means the IP you choose doesn't matter. It absolutely does. It means IP choice is necessary, but it is not sufficient on its own. A residential or mobile IP from a reputable pool solves the reputation layer. And there's nothing at all for the TLS fingerprint layer, nothing for the browser automation fingerprint layer, and nothing for the behavioral layer, because all three of those live entirely inside your own client stack, not inside the proxy. If your workflow needs a real rendered browser, JavaScript-heavy pages, content that only shows up after client-side rendering, interactions that need an actual DOM, you're going to be evaluated on all four layers, and the proxy only answers one of them. If curl is actually sufficient for whatever you're targeting, a plain HTML response, a straightforward AP endpoint, static content that doesn't need rendering, you skip the TERLAS mismatch problem and the JavaScript environment problem entirely, just by not needing a rendered browser at all. And I want to be straight with you here, because this is where a lot of proxy marketing gets dishonest. No proxy, no technique, no fingerprint spoofing library out there makes a request undetectable, and nothing guarantees your scraper stays unblocked forever. Detection systems change constantly. Whatever passes today isn't permanent, it's a snapshot. Any scraping you run should stay inside the target site's terms of service and whatever law applies to you, and stay away from personal data and paywalled content, full stop. The point of understanding these layers isn't to help you defeat detection. It's to help you know, honestly, which part of your own stack is actually causing the block you're staring at. Instead of blaming the proxy for a problem that's actually sitting in your TLS library or in your automation framework's default fingerprint. That distinction alone will save you more debugging time than almost anything else here. I run the proxies behind real scrapers myself, and if you want to go deeper on how residential, mobile, and data center proxies actually differ, and where each one genuinely fits into a scraping workflow, the full written guides and the proxy setups I actually use are at proxyscraping.org. Full written guides plus tested proxy picks at proxyscraping.org, so go take a look and subscribe if you want more of this.